right, so we're going to get started with the next panel, which is about Ken's work in general equilibrium theory. So, of course, it's impossible to overstate the impact of Ken's work in general equilibrium theory. It's also impossible to overstate the importance of general equilibrium theory within economics, not just as a pillar of economic theory and the way that we understand competitive markets, but also as a backbone for the way that we understand many different fields as diverse as macroeconomics, finance, international trade, development, public finance, and many others. So with no further ado, we'll start with John.
Thank you, Chris. So I'm going to speak for 2/3 of my talk from some notes that I prepared for a remembrance for the Econometric Society about Ken's contributions to general equilibrium. So you'll have to forgive me for going over ground that some of you've read. On the other hand, I worked so hard on it, I didn't want to do it all over again. So, can the free market always equilibrate supply and demand, and is the outcome good for society? Ken Arrow and Gerard Debreu settled these two oldest and most important questions of economics through arguments at least as elegant as any that have ever been given in all of economics, using the techniques of convexity and fixed point theory that are still, after 65 years, the most important mathematical devices in mathematical economics. More than any other, their model crystallized the mathematical axiomatic approach that transformed economics from a field not much more mathematical than its sister social sciences like sociology and psychology into a discipline with the same mathematical rigor as physics and the other hard sciences. It made the heart of economics clear and beautiful. The Arrow-Debreu model was simple enough to be understood immediately by mathematicians with no training in economics, yet general enough, given ever subtler interpretations of the notion of commodity, to encompass a large fraction of economics known up until that time as special cases. Moreover, many subsequent developments in economics could be cast as modifications of pieces of the Arrow-Debreu framework. Today, general equilibrium plays an absolutely central role in fields as diverse as international trade, public finance, development, macroeconomics, and finance, which I'm sure we're going to hear about. When we consider that Arrow not only derived the most fundamental properties of the model, along with Debreu and Mackenzie, but also provided the most significant interpretive extensions, it is no wonder that he remains the youngest Nobel Prize winner in economics for this work. In 1951, Arrow and Debreu simultaneously published identical proofs that every equilibrium is Pareto-optimal, that is, that no other feasible allocation is preferred by every consumer. Their demonstration is so simple and illuminating that it is no exaggeration to call it the most important argument in all of neoclassical economic theory. The old proofs, which still linger in many intermediate textbooks, are complicated and rest on several irrelevant assumptions, including differentiability, concavity, and the unbelievable hypothesis that everybody consumes a strictly positive amount of every good. 3 years after that work, in 1954, Arrow, Debreu, and Mackenzie gave the touchstone proof in economics of the existence of competitive equilibrium. Leon Walrath, the inventor of general equilibrium, had informally suggested that equilibrium would always exist because for every market there's a corresponding price, and by increasing the price in markets for which there's too much demand and decreasing the other prices, the economy would grope its way to equilibrium in which demand equals supply for all markets. Arrow and Hurwitz realized early on that proving the convergence of Walras-Tatomont dynamics was problematic. The great mathematicians von Neumann and Wald recognized that Brouwer's fixed-point theorem might be useful to prove the existence of equilibrium, but each was able to prove the existence of equilibrium in very special cases. On reading the general proof of existence of Nash equilibrium for games by John Nash in 1950, Arrow and Debreu independently realized that a general existence proof for competitive economies must be attainable. By humbly paying careful attention to the precise formulation of the details of the model, that is, by getting their axioms just right, especially concerning zero consumption, they were able to join forces and prove the theorem that had eluded von Neumann and Wald. At first glance, general equilibrium seems to be about the mundane business of trading or allocating apples and oranges and pears. But in one bold interpretive stroke, Arrow showed that general equilibrium is also about trading and allocating risk, and is thus about insurance and stocks and bonds. He imagined that a New York apple is a different commodity depending on how much it is snowing in Paris. That is, he distinguished physical objects depending on the state of nature, which includes a complete description of all uncertainty related to all objects. Before Arrow, uncertainty was represented in financial theory by joint normal distributions, which he replaced with arbitrary random variables in which the possible states of nature take center stage. As Arrow explained, this was a natural step for somebody steeped in statistics, but it immediately implied that the output of a firm or the payoff of a bond could be thought of exactly the same way as a basket of commodities of fruit, where the bond payoff in each state corresponds to the quantity of a different kind of fruit. It meant that the payoff of an insurance contract could be modeled by the cash flows it provides in each state, without worrying that it is not normally distributed. This immediately led Arrow to describe what are now called Arrow securities, namely contingent securities that pay $1 or one apple in exactly one state. The price of a bond or an insurance contract is then just the sum of the prices of its constituent Arrow securities, just as the price of a basket of fruit is the sum of its individual fruit prices. Following Arrow, modern financial theorists soon introduced the fundamental vocabulary of the field, talking of state prices for evaluating securities, and the payoffs of some benchmark securities spanning the payoffs of other target securities, and the no arbitrage relationship that must hold between the target security prices and the spanning benchmark securities prices. The celebrated Black-Scholes model of option pricing, especially in its binomial tree formulation, fits perfectly into this Arrow framework. Okay, that was my summary of what I'd already written. I read even faster than I thought I would. So, so I have a couple minutes. So one of the most enduring qualities of Ken Arrow is that he fearlessly liked to work both sides of the street, as he called it, exulting in the possibility that the view would be completely different on the other side and thus stimulate new thoughts from him or his students. Ken not only inspired his students by his example, he also generously made room for them. If one could imagine a world with a complete set of Arrow securities, then he suggested one should also think about a world in which some of the Arrow securities are missing, or replaced with a smaller number of more realistic composite securities, as Radnor formerly did in 1968. This has come to be called general equilibrium with incomplete markets and is the setting of most of modern finance. I mentioned three different phenomena arising on the other side of the street that have touched me. Of course, because of the missing Arrow securities, equilibrium is no longer Pareto efficient. But more surprisingly, as Herakles Polemarchakis and I were able to show, following a line begun by Joe Stiglitz, because of the missing securities, the existing securities themselves are not traded optimally by the market. Typically, they could have been traded differently to make everyone better off. When the securities promise payments in money and all the Arrow securities are present, the equilibria are finite in number and often unique. But as Andreu, Mas-Colell, and I were able to show, simultaneously with Dave Cass and Eve Velasco, take away just one Arrow security and there are typically many dimensions of equilibria, where the dimension stays the same no matter how many Arrow securities are missing. Finally, the Arrow-Debreu framework does not allow for default. At one time, Arrow regarded default as unimportant because he felt that lenders price promises not at face value, but according to the actual deliveries they foresee. One might as well relabel the defaulting promises with their actual deliveries. Perhaps to some small extent influenced by me and others, he came to see that when markets are incomplete, lenders will act to change the deliveries by requiring collateral or punishment to mitigate defaults, and this will have macroeconomic consequences. Frank Hahn summed up this and similar results by saying that the world suffered grievously from those pesky Arrow securities. Arrow retorted that it was the absence of Arrow securities that caused all the trouble. Near the time of Arrow's 75th birthday, Graciela Chicholminsky, who I think I saw here, and Jeffrey Heel organized a celebratory dinner at Columbia University where toasts were made. I quoted the Platonic dialogue Phaedo, which ends with Phaedo saying about Socrates, as I was saying about Ken, that of all the men I've known, he was the wisest and most just. Ken said, "Please pass the hemlock."
So Bob Lucas is next.
It's an honor to be connected to Ken Arrow in any way you can do it. I'm going to go back. I like John's speech and talk, and I want to get back to that, but I want to do it in a roundabout fashion. The only other time I've given a conference in honor of Ken Arrow was in 2008 when. And I was at the Jerusalem Summer School in Jerusalem, and he had been director or whatever the term is for quite some time, and Eric Maskin was replacing him, and still doing the job. And Eric set up a really nice conference where we come and talk about Ken Arrow and gives one or two lectures to the students So I talked about economic growth and went back to Ken's 1962 paper, Economic Implications of Learning by Doing. So I'm going over what Larry Lau talked in a way. When I give the talk in Jerusalem, none of the young guys had ever heard of this story. I was felt kind of shocked. But I see here we got the older crowd, and and we all want to talk about it. But it's also a nice indication of the range of Ken's his range. I can tell you about why I like this paper, because it's really cool, and it basically builds on the work that Robert Solow did, and if you're old enough, Solow's work. The first, everything I've seen that was used with a differential equation. I mean, we were really out of it in those days, and in long-term growth just was stuff I had in class was just incoherent stuff, people telling stories. And here's this guy's a little short paper. He looks kind of reasonable. It says capturing things that are really happening in the real world, and you got to work out exactly what's going to happen. And I bet a dime that when Ken was working on his paper, that he was stimulated like all the rest of us older people, but by Solow's paper. His students certainly were. So I think of the people who came out in my year from Stanford: Carl Schell, David Cass, Menachem Yari, and I want to say Uzawa, but Uzawa wasn't exactly a student. I never knew quite how to type. A group of people all interested in, stimulated in doing something with what Solow had got us into. And I found that group was, I envied them. One of the group, this Cass-Koopmans model, Cass contributed to it, was he kind of added in a supply side and a demand side in the model. It's basically a Solow model, and I guess that's what Koopmans did the same thing. And it's now when you're talking about giving a talk on economic growth, it's the Cass-Koopmans model, which is what everyone starts with, and then you can go in all kinds of different directions. Now, this was an actual economic model with supply and demand and so forth, and people just weren't doing that in macro. People had so that's one thing. But the second thing is that of Solo's paper is that you could match up the objects in his paper with objects that you can go out and, like national income and product accounts, or a whole. So you had a model, and it had data, and you got to sort of make some connection between the model and the data. There's something to be. Now that doesn't come across in John's model, because he's looking at the pure. He's just looking at a particular model and working out its properties. But what do you do with these properties when you've got it? So I think that there were a lot of people who were trying to connect up general equilibrium theory to data. Not everybody, but a lot of people were, and Arrow and Andreu had set this beautiful arrangement out in front of us, and you could without really, you could write down models which you could determine what's going on in the model from the style of the Arrow, Andreu, Mackenzie work, and you could work on it. So you could play around with, if your model didn't fit the data, you could vary it in a lot of different ways. And there was a huge number of people who got into that, including me, but including all the people I've listed too. Now we weren't obviously we were going to specialize the general equilibrium model to something way simpler, but we could use the math to conclude that this is going to do. We could work out the models. It changed the whole. It got us going in a different, and I think hugely more productive direction about macro models, what they should look like, what they could look like, what fits the data, what doesn't. Okay, no, that was huge, and it's still going on. But it doesn't actually settle anything, does it? Because once you get into stochastic shocks, glitches of some kind, the Solo model you're sailing along on average with the same at the same rate for now. Of course, it's amazing how close that is to the UK and the U.S. history, but it's not that close. I mean, we did have a crash in '29. We didn't know it was coming, but we certainly had a nice one in 2008. So there's a lot more going on than just sailing along that model. But you don't want to throw away the model either. So you're adding in some stuff, some stochastic stuff, and it fits in with the Arrow de Brugge stuff, but you can play with that and see if you can make some sense out of the fluctuations as well as the growth rates. And that's a mixed bag. My own thinking was probably because I worked with Milton Friedman, that all the fluctuations was due to something going wrong with the money supply, okay? And you could work that out, and but that didn't turn out to be even close to what really happens. I could write down a model and get something to happen, but when I tried to match it up to stuff that actually happens, I couldn't get it. Believe me, I worked hard on it. I just couldn't get it to go. Later on, Keynes and Prescott took that same sort of setup and threw away the money supply, the money stuff, and just had a shock, meaning some random things to production or something. And that worked better than mine. But what are they? What are these shocks? Now, Kenneth and Prescott were running before the 2008 crash, so being super smooth between World War II, it looks pretty good. I mean, basically, it just says, let's throw away the stochastic stuff and just go back to Sol's model. But again, you're missing something. The thing is not, so far, the models that have done this, and they've definitely rested on overlapping generations model, there's some work to be done. So, thank you.
So next speaker is Andreu and Mas-Colell.
Glad to be here. I'll cover one aspect of Arrow's work in general equilibrium, namely stability. Economics is grounded on the notion of equilibrium, defined as a situation where the plans of all economic agents are compatible. It is a most natural question to ask how the equilibrium is reached, or more modestly, if it is stable in the sense that a small perturbation in the system will be reabsorbed and the equilibrium reestablished. There are two well-known difficulties in the analysis of stability. The first is that an economy can be in disequilibrium in many different ways. The second is that, in contrast with the physical science, there are suggestive but not exact dynamic laws for behavior out of equilibrium. To face these difficulties, there are two approaches that make the point. One consists in expanding the original model and then examining the internal dynamics of an equilibrium for convergence to stationary points that corresponds to equilibria of the original model. So far, so good, but in rigor, this only gives rise to an infinite regress. The second is simply to proclaim the stability issue uninteresting because it has to include features that are somewhat arbitrary. However, it seems to me, and it has seemed to many economists, including Arrow, that it is interesting, even if it has to reduce itself to the analysis of a variety of disequilibrium situations and plausible dynamics. If you do not have some heuristic justification for the at least local stability of your equilibrium, then you perform equilibrium analysis at your own risk. The problem of stability of a general equilibrium system was posed by the founder of the theory, Léon Walras, and in a very particular form. He assumed first that the law of one price always holds, no stability analysis on this aspect. Second, he did not impose feasibility out of equilibrium, hence the dynamic is on plans, not on realizations. The Walrasian tradition, although not him, has also assumed that the quantities, production and consumptions, are instantly adjusted. And again, no stability analysis is carried on those. Therefore, a disequilibrium situation is specified by a price system and consumptions at productions that are individual optimizing, yes, not compatible in the aggregate. In this setting, the class of plausible dynamics is clear. The price goes down or up if the excess demand is positive or negative. Walras expressed this nicely by the construct of an auctioneer that calls and moves prices until an equilibrium is reached, and which points real transaction takes place. It's the famous tâtonnement. The condition of stability is then obvious enough. Stability obtains if when the price is above equilibrium, supply is larger than demand, hence price will go down. Conversely, if it is below, it's the lower demand. As a function of prices, excess demand is decreasing. Arrow and his main collaborator in this endeavor, Leo Hurwitz, got to stability analysis from two different traditions. On the one hand, he alone and with Gerard Debreu had formulated the most general version of the general equilibrium multi-agent model. On the other, Arrow and Hurwitz had studied in depth gradient disequilibrium dynamics for linear and nonlinear programming. Those originated on a proposal of Brown and Boyd-Neumann for zero-sum games. In a beautiful paper published in the Hodling Festschrift, they established an intimate connection of these dynamics with Walras tâtonnement in the context of a single consumer problem. Essentially, Arrow and Hurwitz show that it is the tâtonnement dynamics, but with no instantaneous adjustment of quantities. the Lagrange multiplier being prices. More important, they established the local and global stability of the gradient dynamics. After this success, they have gotten stability, the logical next step was to study the problem in the multi-agent case, so well known to them. To do so, Arrow and Hurwitz kept the framework of Balras Tatonement. I note that in Arrow's first and most Google-cited paper on price adjustment, he displays much awareness of how unrealistic the auctioneer device is and how complex this equilibrium analysis can be without it. I quote, "In this equilibrium, the market consists of a number of monopolies facing a number of monopsonies, or the whole adjustment process is apt to be very irregular." Indeed, Arrow, I could say that Arrow could fly very high, but never lost the view of the ground. At any rate, in this research program, Arrow and Hurwitz got a first important result: the local and global stability of Tatonement price dynamics when the aggregate excess demand function satisfies the weak axiom of revealed preference introduced by Samuelson in the context of choice theory. It was known that it had a stability implication, but it was Arrow and Hurwitz that established them in all generality. Essentially, the only restriction, significant globally but not locally, is that the speeds of adjustment have to be constant. The weak axiom is always satisfied in a single consumer economy, but except in the two-good case is more general, because, let me be a bit technical, the individual excess demand satisfies also knife-edge symmetry conditions in the so-called substitution matrices. In contrast, and loosely speaking, the weak axiom condition is robust. A small perturbation does not alter the fulfillment of the condition. An aggregate economy satisfying the weak axiom is a sort of blurred one-consumer economies. In a neighborhood of equilibrium, the weak axiom amounts to the low demand holding for any composite commodities, that is, for any coordinate system. Arrow and Hurwitz, with Bloch, went on to establish local and global stability under very general conditions on the speed of adjustment for aggregate excess demand functions of the gross substitute type. Those are defined by the properties that if the price of a good goes up, then the demand for it goes down, and the demand for every other good goes up. If the number of commodities is moderately large, this is an extremely restrictive condition. For two goods, it may or may not be satisfied, even in a one-consumer economy, but it's a reasonable condition. Arrow and Hurwitz also showed that there was a link between the gross substitution and the weak axiom conditions. Under the gross substitution hypothesis, the weak axiom is always satisfied between an equilibrium price and a non-equilibrium one, or all non-equilibrium excess demands have a positive value at equilibrium prices. This is all needed in the weak axiom case to prove stability. Hence, if the speeds of adjustment are given, the gross substitute result can be viewed as a particular case of a more general theory based on the weak axiom. There is, however, a way, also explored by them, to see that the essence of the gross substitute case can be of more general relevance. Gross substitution trivially implies that the magnitude in absolute value of the flow of income generated by a price move on other goods cannot be larger than the one generated in the own good. If this weaker property, called dominant diagonal, holds at equilibrium, Arrow and Hurwitz, with the precedent of Mackenzie, show that the local stability obtains. Incidentally, it is also the case that the weak axiom also holds locally. Hence, again, the weak axiom provides the general picture. This dominant diagonal result is, in my view, significant. One could ask, why hasn't it become more central to stability analysis? I think it is because it does not generalize nicely to global stability. Yet, in my opinion, global stability, while much stronger as a formal result, is not as important if we think on the economic issues as local stability. Particular disequilibrium settings become increasingly implausible the farther we are from equilibrium. Suggesting that we know how the economy will move far from equilibrium stains credulity. Does this mean that the conditions implying global stability have no value? No, because of an implication of global stability, the uniqueness of equilibrium. I confess that for me, the class of conditions investigated by Arrow Hurwitz are most relevant in these two dimensions, guaranteeing local uniqueness and yielding the uniqueness of equilibrium. Since examples of multiple equilibrium were known, Arrow and Hurwitz were well aware that not every equilibrium could be globally stable. Nonetheless, they show that for the one-dimensional case to goods, the tautology was simple system stable, meaning that from any initial point there is convergence to some equilibrium. From here, they went on to make a most intriguing statement, I quote, "None of the results so far obtained contradicts the proposition that under perfect competition, the system is always stable." Did they mean it? After all, Arrow knew from existing analysis how more complex the multi-agent situation was from the single agent one, even if blurred. Or was it perhaps simply a trick to stimulate research? Be as it may, it was quite a challenge, and stimulate research it did. In short order, Scarf produced the first example of a three-good economy with a unique equilibrium that was locally stable for the tautology. So if there were hopes for a general system stability, there were dashed. The example showed that the capacity of symmetric income effects to nullify the good properties of substitution metrics should not be underestimated. Research continued in two lines. One culminates with the Sonnenschein-Mantel-Debré theorem, which for stability implies that any arbitrary dynamics in a space of normalized prices can be viewed as the tautology dynamics of some exchange economy. The other investigates which type of price dynamics could lead to general convergence for economies described as excess demand functions. Two culminations of these lines were a result of Smale formulating a dynamics with a property akin to system stability. Convergence is guaranteed from any point at the boundary of the price domain, and of Sari and Simon, showing that for universal system stability, the price dynamic should use information on own and cross price elasticity. The non-availability of a good market interpretation for these dynamics means that they should be shot more as computing mechanism for equilibrium prices more rather than as proxies for market behavior of equilibrium. I imagine Arrow followed all this from afar, but with keen interest. Perhaps he thought that this time he had gotten the possibility theorems. Thank you very much.
Right, so the final speaker is Herakles Polemarchakis.
Thank you. So Arrow loved arguing, which was what was most attractive about him, especially because it came hand in hand with a deep, genuine concern for the human condition, and the combination of the two was what was remarkable. And I realized how much he loved arguing in a rather strange way. Soon after I met him, very often in conversations I couldn't follow what he said, and I would ask him to explain, and I realized that this request would go unnoticed. And the only way to get a response when I didn't understand something was to say, "This is wrong." And that was wonderful. I mean, it would do wonders in terms of explanations being forthcoming. Only very frequently, of course, he would look far beyond and be nice to me and say that I had seen something he had failed to notice. But anyway, so Chris introduced the session by saying that the importance and central place of general equilibrium in economic theory is beyond dispute. Now, there is a quick and immediate way to assess whether this is the case, and that is to look at the weight of general equilibrium in a graduate curriculum. And there the results are mixed. Now, they are mixed in the following sense. There are two views of general equilibrium. One is what I would call the narrow view. The pejorative way to refer to it would be existence proofs. Okay? The narrow view refers to the classical existence results and properties of the review of the derivation of the welfare theorems. That's a narrow view. But there is a much broader view that considers general equilibrium not like any other field of specialization, but as a framework within which research in other areas, diverse other areas of economics, as John pointed out, is developed it serves as a test of the consistency of the arguments, and we see it in areas like monetary economics, macroeconomics, finance, that today carry the mantle of general equilibrium, I'm afraid, more than courses in pure theory do. Now, I would have liked to say that Arrow had that second, broader, all-encompassing view of general equilibrium, but I don't think so. I think Arrow was a problem solver, and that was, I think, I'm repeating here what we already heard from Mordechai, and he was not what one might call a grand theorizer, and I shall explain what I mean by this later on, but what characterized his work was the desire to solve particular problems. And let me give examples. We heard Eric Maskin described social choice theory as posing the broadest of possible questions in social science. How should societies make decisions? Now, we heard from Mordechai that Arrow was prompted to work on the problem, having faced the question of aggregation of preferences in the formulation of war games or consulting concerning military situations. Now, if in one of the reviews I read, accounts that he gave of his work in social choice, he gave another example of the problem he was trying to address and that led him to the formulation of the social choice problem, and that was the problem of the aggregation of preferences among shareholders of a firm. Now, his work on uncertainty, he says explicitly that he was prompted to work on it by a desire to formalize, to clarify Tobin's work on liquidity preference. So the existence problem, I think, was an attempt to solve, to clean up the argument that had been presented by Hicks and earlier, of course, by Walras and other less formal existence, less complete existence proofs without cutting corners in terms of the formulation of production. And he saw it as the problem of the conditions under which interconnected markets could attain an equilibrium. Okay. Now, of course, he had a keen eye for the problems that would cause the arguments to fail, and that's why he thought the problem of zero prices and zero endowments were so important. Now, there is something interesting about the two proofs that Arrow and Debré gave for the existence of competitive equilibria. Now, the papers were written, the existence proofs that were published jointly, but they started out as two separately written papers. And I think it was Koopmans that asked them to merge the two papers into one. And Arrow, and apparently the two proofs, the two existing papers before the merge, each had a mistake. Okay. Now, I heard the story from Arrow, so I don't know what Arrow's mistake was, but he pointed out that, what Debré had overlooked was the boundary and down problem that later, of course, led to the work of Mackenzie on resource relatedness and was somehow covered up in the original existence proof, not by making not interiority assumptions, but more or less interiority assumptions. Now, according to Frank Hahn, there are two pillars of competitive equilibrium theory: rationality and market clearing. Now, you would expect Arrow to be a staunch supporter of rationality. However, he went out of his way to point out that rationality is, after all, one way of modeling individual behavior. And actually, he was very bothered by the, Hugo is here somewhere, the fire that was lit by Hugo's argument about the properties of aggregate excess demand, and the fact that on the aggregate very little can be said, can be deduced from rationality. And Arrow made extreme statements to the effect that rationality, unless it is coupled with other assumptions about the characteristics of individuals, does not lead anywhere. Now, I think there has been work recently by Rosa Matskin and Don Brown, among others, that have somehow questioned the claim that rationality has no implications by in itself. But anyway, Arrow was very kind of confirmed, this result confirmed his conviction that rationality was neither necessary nor sufficient as an ingredient in the construction of arguments in economics. Furthermore, as another example, concerning market clearing, Arrow did not cease to repeat how to point out the failure of markets to clear, labor markets in particular, and he thought of Keynesian economics, of all things, as the way to salvage the optimality results and the good outcomes that we get from the first and second welfare theorem under assumptions that are very strong and he would consider unreasonable. And Keynes saved the day by arguing, according to Arrow, that even though markets on their own may not lead to these optimal allocations, government intervention might do the job. Now, and mind you, Arrow was willing to take very seriously Keynesian arguments, even though he explicitly said that economic theory, and by this I think he meant general equilibrium theory, had failed to absorb Keynesian economics or even monetary economics, as he said then, and construct complete arguments. So Arrow did not see the classical welfare economics as a distant but nevertheless justification, defense of the market mechanism as a way for allocating resources in an economy. It is in a paper that he wrote later, late in life, so to speak, called A Cautious Case for Socialism. It is not an exaggeration to say that he said that his position was that the argument can go both ways. There are arguments that those who are for socialist allocation ignore, but he also pointed out there are similarly arguments that those who argue for the market ignore, that he was clearly, could not take a position for one or for the other. Now, so Arrow solved problems, but of course what was his strength was the fact that his analytical ability was such that he would go to the root of the problem, and by going to the root of the problem, he would set the foundations for whole fields of research to flourish. I would like to conclude with a remark that was made by a physicist, Steven Weinberg, who, a famous physicist. He also wrote a popular book called The First 3 Minutes that was very nice about the first 3 minutes of the universe. He also wrote an article in the New York Review of Books around the year 2000, where he talked about the AHA criterion. And what is the AHA criterion? The question that Weinberg wanted to answer is, what is it that makes for a great paper in science? More specifically, the distinction between description and explanation or understanding, but more broadly, what makes for a great paper. And Weinberg went through a list of possible criteria: elegance, generality, applicability, what have you. And for each one of them, he had counterexamples of papers that people would consider are fundamental, yet they failed the particular criterion. And Weinberg concluded by saying that at the end of the day, the criterion is whether when you read the paper, at the end, your reaction is a loud aha. I understood something that I had not understood before. And it's hard to think of somebody whose papers satisfied the aha criterion more than Arrow. Thank you.
So perhaps fittingly, in a session on general equilibrium theory, all of our speakers took their time constraints as given. So we have a little bit of extra time to have some discussion. So let's maybe start by going back through our speakers to see if they have any comments to add, and then if we have time, we'll open it up for questions from the floor.
Well, I have a question that actually I thought maybe Bob answered, but I was not sure. So somewhere a transition was made in macroeconomics from the aggregate consumption function approach that Tobin championed to a more representative agent or maybe heterogeneous agent optimizing approach that resembles general equilibrium more. And I was wondering whether you could say a word about when that happened exactly. When did that happen?
Well, you could say it was Solo's model, but I would say, oh. I mean, it's clear from Solo's original model that's the direction we're taking. The Cass-Koopmans model has agents who live forever. They make trades. They eat the stuff that somebody produces. I mean, it's just a total economic model, except that it runs forever. Then you got to work a little bit to get that. But it's basically right there. And I don't know what you mean by consumption function. You mean something like
No, there's the C plus I plus G and all that. The C is, they weren't based on utility maximization. They're based on a behavioral rule that seemed to fit the facts.
No, I mean, that's just not true. Everyone's got a choice about whether I consume what I get or whether I turn it into a piece of something that can last forever. So you have to choose between, and then you could, if you want to trick it up a little bit, you could say, you could do some leisure instead of working, but it's all, it's nothing to do with C plus I plus G, except that the data that underlies C and I and G, which are not theories, they're just there as but it's quite separate from the theoretical model, which is just a standard theoretical model. But
Well, I think you're not taking enough credit for a transformation.
Yes,
that happened.
he is asking, there was a time that micro and macro were two separate fields.
well, we start to hell with the micro guys on that. I mean, we're macro. I don't know who's the right guy, but there's one.
They merged.
Yeah.
Yeah,
Right,
but
I think that's what he's talking
that's
about.
what I'm saying. There's been a general convergence of fields. I mean, finance was also, it wasn't even taught to undergraduates in many schools. And macro had a completely different methodology from micro. And now all these fields have become, use the same basic methodology. And a lot of it, not all of it, but a substantial part of it is the general equilibrium methodology.
That's not quite right. I mean, stuff happens, like a crash in 2008 or in and none of the models that I've described actually have a satisfactory explanation or even description in theory about how that would occur. It's just it's just off the charts or something like that. We, if we're going to correct, make the economy safer on that, somebody's going to have to find something that no one has so far, in my opinion. A lot of guys think they have it, but it's a hard problem. I think we're not talking about we're not talking about models now. We're talking about the connections between models and evidence, and you can't make it fit. I mean, you either got it right or you don't. Every science has that. I mean, there's all kinds of stuff that you might wish you could do and you don't know how to do it. You think you're supposed to know everything? I mean, no other field, no other field says that's our job.
No, I'm not. I'm not trying to place a bigger burden on you. On the contrary, I'm saying.
Well, I'll take care of my own burdens.
Well, playing by the same rules now.
All right, do we have time for a couple of questions from the floor? If people want to wade in. William.
So this relates to the issue of stability and convergence that Andreu talked about, and there were some criticisms from computer scientists recently about just it being too hard in general to find an equilibrium, because we know the anything goes theorem, so we know it's a general fixed point of some general function, and they have things like PPAD completeness, which is supposed to show that in general we cannot find an equilibrium, and some computer scientists say, well, if my laptop cannot find an equilibrium, then the economy cannot find it either. So my question is, what's kind of the modern thinking about this, and how much sleep should we lose over this problem?
I don't know if I could repeat.
He's saying it's very hard to find an equilibrium, and so given that, how much sleep should we lose over it?
We have to think about it.
Well, I think you should lose some sleep. If you have an equilibrium which then you experiment around with departures and you somehow are being sent in directions you don't want, I think it deserves losing some sleep, looking more to it. I didn't say that Arrow, some of the interesting things of Arrow's, also Arrow and Hurwitz of Arrow by himself, and Arrow with Nerloff, also tried to link stability analysis to anticipations and to forecasting. And so they were very aware that that had to say something about how markets function. So yes, you should lose some sleep.